everyone, and welcome to another edition of Tink Talks. Today we're going to extract the DNA out of a strawberry. Now, there are a number of other fruits, say bananas, you could extract the DNA from as well, but in my opinion, the strawberry works best. One of the reasons, probably the primary reasons why strawberries work so well is that they are, in terms of their genome, they are octoploid. Octoploid, octo meaning 8, so they have 8 copies for each of their chromosomes. Whereas, for example, in humans, we are diploid, which means we only have 2 copies of each chromosome. So strawberries have an enormous genome. Plus, they're easily obtainable, you can smash them pretty easily, and they're delicious as well. So, this is something that does not need to be done in a lab. This is an activity that can be done at home. So those of you who are at home during our period of quarantine right now, and you're looking for some activities to do with your kids or even just for yourself out of your own interest, you can go ahead and extract the DNA from a strawberry. So here are the materials that you'll need. Ziploc bag. You'll need a solution that is soapy and salty. And the ratio to make this solution this would be a ratio of dish liquid to water to salt. Okay, this is a very simple ratio. It's 1 part dish liquid to 18 parts water to 0.5 parts salt. Okay, so for example, with this solution that I made here, I used 90 milliliters of water, 5 milliliters of dish liquid, and about a half a teaspoon of salt. And I mixed it all together, and so this creates this soapy, salty solution. You're going to have to get something. A funnel works great if you have that. I'm using test tubes here, which you may not obviously have readily available at home, but I don't know, maybe a thin vase you could use as well. It would work, and just about any thin glass tube would be appropriate for this. You need, you have to have some kind of alcohol. You can use ethanol, which I have here. This is 95% ethanol. You can also use 70% isopropanol or rubbing alcohol, or 91% works as well. And make sure that it's ice cold. Okay, now it doesn't freeze in the freezer because the freezing point of alcohol is much lower than the temperature in the freezer. So you can throw this in the freezer and it will stay liquid. So this is some cold ethanol. Let's see here. Oh, you'll need sorry, I dropped it. You'll need some type of a filter. Cheesecloth works really well. A coffee filter will work, but it's a little too tight. You can see in the cheesecloth, the openings are pretty wide apart, so it allows the fluid to seep through it, which you'll see in a few minutes here. But a coffee filter does work, but you're going to have to do one part of the experiment for a little bit longer period of time. Let's see. I think, you need a glass stirring rod. You may not have one of those. Coffee stirrer or tweezers. Tweezers work well also to obtain the DNA. That's the purpose of this. Okay, I think we have everything. Wait a minute, no we don't. This is a strawberry DNA extraction. You need a strawberry as well. How could I forget? Silly Tink. Okay, so what we're going to do here first of all is we'll take the strawberry, put it in the Ziploc bag, and pulverize it. Now, I have one pretty massive strawberry here. You can use more than one. In fact, I'm going to throw in another one here that's really ripe, because the riper the strawberry, the better the results. It just makes it easier for the strawberry to break down and to break open the cell walls. So what you want to do is try to squeeze the air out of the Ziploc bag. It doesn't have to be totally air-free. This doesn't have to be in a vacuum-sealed bag. And you just pulverize the strawberry, and you smash it. Now, you don't hit it with your fists. I've done this many times with students, and so many times they just want to take out all their frustrations on the strawberry. Please refrain from doing that, because the bag will tear, and then you will have strawberry juice all over the place. Unless that's your design, maybe that's what you want to do. is have strawberry juice squirting all over the place. I personally prefer not to have that occur. So I'm going to smash, pulverize, smash, pulverize. And you can see the juices are abundant in a strawberry. And so we end up with this juicy pulp here. Let's see, I've been pulverizing for about a minute here. I need to go a little bit longer. Let's see if I can think of a story to tell you. Yes, I have one for you. Once when I was, I must have been about 10, 11 years old. I think it was about 10 or 11 years old, yeah. And I thought I was going to make an enormous amount of money picking strawberries at a strawberry patch near my house. So I decided, yep, this is what I'm going to do this summer. I'm going to make thousands of dollars picking strawberries. So I went one day, rode my bike down to the strawberry patch. I started picking, and I lasted about maybe 2 hours, and turned in my pints of strawberries. I made about 25 cents, and I said, forget it. This is not something that I'm going to do. So I never got into picking strawberries, never began my strawberry picking enterprise that I thought was going to make me rich. It didn't work out too well for me. So there you go. That's a fun time filler, wasn't it? Did you enjoy that story? I didn't think so. So what I'm going to do then is I'm going to pour some of this salty solution down into the bag. I'm going to stir that up a little bit. Use my coffee stirrer. Stir that up. Get the salt mixed up in it as well with the soap bubbles too. Okay, so we're going to pour a little bit of that in there, and I'm not measuring this very carefully, but that should do. Okay, then I'm going to mash this up a little bit longer, just to help break down cell walls, and especially the cell membranes, but also to kind of help the DNA become more concentrated. See what's happening here, and of course you can't see this. This would be at a microscopic level, is that we're using soap. Soap has a hydrophilic and a hydrophobic end, so that's a water-loving and water-fearing part to the soap molecules. Well, there happens to be a water-fearing and a water-loving part of cell membranes as well. So what the soap does is it helps to break down the cell membranes around each individual strawberry cell. And then the salts, what they do is they allow for the DNA to clump up a little more and become a little more concentrated. And how does that happen, you ask? Well, the salt will create regions of charge. And as a result, then, it'll repel the DNA molecules, and it'll help them clump up. Also, the salts attract the proteins that are within the cells, and they pull the proteins away from the DNA so that the DNA then will be more concentrated. So basically what this is doing, this soapy, salty solution, is, number one, the soapy part is breaking down cell membranes and also nuclear membranes as well, because that's what's called a phospholipid bilayer. And so as that phospholipid bilayer breaks apart, the cells break open, the nuclei break open, the DNA comes out. And then the salt, because of the charges that are on it, will help the DNA to become more concentrated. And so therefore you're going to have better results whenever you extract your DNA from the strawberries, and then you can see it more easily. Okay, so the next part, what we're going to do is we're going to take this pulpy mixture, and we're going to separate the liquid part of it from all of the strawberry pulp. And here's where the cheesecloth comes into play. I like to call this, instead of cheesecloth, strawberry cloth, because we're using strawberries. So open up your Ziploc bag, and what you'll do is just gently pour it into the cheesecloth. You don't want it to fall down into your funnel. And what will happen is, and I'll show you this, of course, so you can't see this now. All you're looking at here is a blob of strawberry on cheesecloth. Is I'm pouring this pulpy mixture, soapy, salty mixture, and the cheesecloth, of course, is capturing all of the pulp, and it's allowing the strawberry juice to drain down through. So we'll let that go for a little bit, and what you can do is you can kind of squeeze it a little bit, but you don't want the strawberry the pulp to run out the side. We just want to let the juice filter down through and run down through. So I had quite a bit of fluid in there because I used so much strawberry. So I'm going to let this juice run down for a couple seconds more while I'm squeezing at the same time to try to get more juice out of it. And that should be good. And set that aside. I'll eat that later. Okay, now what you can see, and I'll show this to you on the side, is here is our soapy, salty strawberry blend. Just that color there. The suds are going to interfere a little bit, but it should be fine. So I'll put the funnel back on. I'll take the ice cold ethanol, and I'll gently pour some of that down into the test tube here, using the funnel to help guide it through. And pour a little bit more down in there. It's a pretty large test tube, so I want you to be able to see it, and I want to be able to get at it pretty easily as well. Okay, so I'll remove the funnel, and what you see on the top here is this cloudy substance here that is formed right here down the sides, and you can see it how it kind of clings to one side of the test tube, and under here as well. This is where the DNA and the alcohol has now formed here. And what has happened, like I said, is that the DNA has separated, and the ethanol is causing the DNA to separate from the solution that was down here because of the strong non-polarity of the ethanol. DNA is not soluble in ethanol. And so as a result, the DNA will clump up because it won't dissolve within the ethanol. And so those two are separating basically apart from each other. And why do I use ice cold? Well, the temperature of the ethanol can help with the clumping up. It'll cause more efficient clumping, faster clumping. So think of, the molecular motion of the ethanol. The molecular motion is slowed way down, and so as a result, it's going to slow down the motion of the DNA as well and cause it to clump up even more. And so you can see here what the DNA looks like up close there. Now, you can put this under a microscope and use 400x. You could even, if you get it thin enough, you can also use 1000x under a microscope, but it doesn't, of course, show you the double helix structure of the DNA. Now, the big question is then, what do you do with this? Well, you kind of just look at it and you say, hey, I extracted DNA from a strawberry. That's pretty cool. And I suppose it is. I mean, that's what this is. All the rest of the strawberry, the pulp, of course, is in the cheesecloth. But what remains then down here would be the rest of the juices that are within the strawberry and other organic molecules as well that are down here in the red area of the test tube. Okay, you can still see that the DNA is still precipitating out of the strawberry solution. All these, I'm going to set this down, use the coffee stir. All these wispy bands that are starting to form here, these are all still precipitating, coming out of the strawberry juice and the salty soap solution. And they're rising up to the top. Ethanol has a lower density than the strawberry juice solution, so the ethanol is going to sit up top. And as long as the ethanol is up there, the DNA will continue to clump up, so the ethanol does not mix in with the solution, nor does the DNA dissolve in the ethanol. So it works out great. And like I said, you probably don't have access to 95% ethanol, so you can use rubbing alcohol as well. 70% works well, 91% works well, but the part of the key is to make sure that it goes in the freezer and leave it in there for, even just a half an hour is plenty of time for it to cool down enough that you'll be able to have these very visible results. So anyway, that's the end of this edition of Tink Talks. I hope you enjoyed the strawberry DNA extraction. And like I said, give it a try. It's very easy. You can use at-home materials to do this. And it might be something that'll really fascinate your kids. They may enjoy it and find something else to study and to research and then to learn about DNA and genetics and chromosomes and on and on. And you can even try other foods as well. Like I said, bananas will work well to get the DNA out of them also. So I hope you enjoyed this video. Thank you for watching, and please, if you haven't, and you like this video, please subscribe, share it with others, spread the word, and hopefully we can have other people give this experiment a try as well.